this session, we'll be learning how to do a microfluidic chip designing. Before that, we'll first of all open the assembly file. And in the assembly file, you can just insert the new part. So after installing new part, then just click on it and go to edit part. In the edit part, choose the front plane, and according to our dimensions, so these are our dimensions, and the overall chip length and width are 75 and 24 across. So then choose the center rectangle, and I've given the dimensions 25 cross 75. Go to features, next to the boss, and the thickness of this is and the thickness we maintain as 2 mm. So put it as 2 mm. Look okay. After that, on the top of this, we'll be creating the microfluidic design. To do that, you can just click on this, go to sketch, and here we have a design of this, something of this kind. So then we have an inlet radius, diameter and length with a serpentine channel length, width and diameter, and the optical zone, zone 3, and the head zone. This is the final zone. Okay, from the design, now we'll go to draw the inlet of the, that is the starting of the design. To do that, first of all, we just draw a circle. Circle was given a diameter of 2 mm. Okay, and we constrain the circle with respect to the edge, and for now let's keep it as a 3 mm. Okay, and we can see it is still blue in color, that is underdefined. So once you create a center line, that center line is now in collinear with the center, so that it changes to a fully defined case. And now it is given that there is another circle, another inlet of same diameter 2 mm. Okay, and then we create another center line of this. Okay, and now we just keep the distance for now as 5 mm. Okay. And then the channel length as specified, so it is like, it should be 7 mm. So this is 3.5 mm from here. We just mirror this about this plane, so this will be again the complete 7.5 mm. And then from here create a 10 mm channel. This is 10 mm, and again we just mirror the same this 10 mm. Okay, and again we'll just go back to the design where we can see, okay, there is a another channel of coming from the second inlet, and it's a flow focusing channel, and then we just join this here, and we can do full channel of this. So this completes our first design, and then use the trim option to remove this and this. Sorry, we will not remove it now, we can remove it later. Okay, So then we'll go for the serpentine design. That is, it is having a 0.5 mm of this length. So we can give it a 0.5 mm. Or instead, yeah, you can go with 0.5 mm. And then according to this, it is of length of serpentine channel is 16 and 17 mm. So to do 17 mm, okay, and then to do 17 mm, you can just select the midline and you can create a first 17 mm line. Yes. So once the 17 mm line is created, and you can see the first half is not required and second half is required. You can just create another line, and this can have a 17 mm length, and we are yet to finalize the width. So this should be the exactly half. So you can just constrain this line to be any of the center line and make it collinear. That is this line and this line, make it collinear. Okay, so now you have a center line fixed, and only thing is you have to give the height, length, the difference. So that we'll see it from here, and so that it is given. Okay, so there should be 1, 2, 3, 4, 5 serpentine rings, or 6 serpentine rings. 6 serpentine rings in 16 mm. We can divide it later. It can be like for now randomly just give the 6 rings. So 1, 2, 3, 4, 5 and 6. I think it is matching with this. Yes, 1, 2, 3, 4, 5, 6. Yes, and then specify the radius. No, they didn't specify anything, and they have given the final length as the 16 mm. So 16 mm is from first serpentine start to the last serpentine end. So that is from here to here. So it is given as 16 mm fixed. Okay, now 16 mm is fixed, so we have to arrange the equidistance. So that you just click this and okay. 1, 2, 3, 4, 5. Let's say for 3 mm, and try to do it as 3 mm, 3 mm, 3 mm, and this is again, but it's not taking, so finally it should be. So we'll try to adjust all the channels in a length of 16 mm, and now you can see there is a constraint, like it's not fully defined in the x-axis, however the y-axis is completely constrained. So to do this, you just go to this line and select this line and make both collinear, and the same with this line and this next line, make it collinear. and the line dash, left line, and the left line make it collinear. So now you can see the formation of a complete defined. So now the sketch is fully defined, but however we have a, like, this thing is not defined, so that is the reason it is showing the underdefined. We'll go back to the sketch and we can see this. So the overall length, it is 5 and a radius of 2.5 of this. So we can create it. So we'll choose a random. So we can create a 2.5 and then we'll create a circle of a radius. It's given as 2.5, so diameter 5. Right. So this will increase to 7.5. And further, the next line you can start to give as the next 7.5. Okay, and then we'll go back to design, and then we have a Y-shaped channel. The Y optical zone channel we have 2.5, diameter 5, and length as 5, and then the head zone we have to create 16.5 length and width as 16 mm. Okay, first of all we just create a Y, and the angle will be 135 degrees. Okay, so randomly I'm just creating a Y. Go back to this design Y, and then we have a random edge junction. And then we passing with another edge junction. Okay, and let's make it constrained one side. To go back to the design. So this Y is having a overall length of 16.5. Yeah. So this one here should be 16.5 mm. Okay, so the outer we have drawn it, and then the space is given as 4 mm. So it's 4 mm spacing and 135. Yes, we can get it a 4 mm spacing. This is constrained. Now we just have to specify the length of this. So it is given as 16. So 16, it means that this should be 8, and if that is 8, this should also be 8, and then we just have to specify the final gap between these two. So gap we maintain as it's 4. The gap can be 4. Then we just have to constrain this one line. we can just press this, or we can give a length of 4 mm. Okay, now everything is constrained. Then it is very simple, just create a mirror and cross 1, 2, 3 and 4 lines. Mirror about this axis. Give it a second time. Right, so we have done everything. Now we just have to create, and this we have given is 0.5, so let's increase this. Let's do. Okay. Now everything is set and we are in fully defined case. And what we do is just we do a little fillet things. So these are all the sharp ends. Change the radius to, let's say, 2 mm. So 2 mm is too much. Let's try 0.5 mm. Yes, so 0.5 mm is fine. So just create the fillets, 0.5 mm. Okay, just press OK. Now all the fillets are created. Yes. And now let's try to create our microfluidic channels. Just by creating an offset, press offset, and we want a channel of 1 mm. Let's see the channel length as channel width is D is 2. So it is 2 mm, and for that we'll add 1 mm, but you can do a bidirectional. So bidirectional, it means 1 mm on both sides, and then create the base geometry as a construction line. And you just select lines, so you see, so I think it should be 0.5 mm. Yeah, 0.5 mm, and then just select the lines. You can see the lines, formation of lines. Okay, now everything is selected and create OK. Now everything is done. Okay, now the next part remaining is the trim operations. So now we have to trim the entities which are not required. So you can see that you have to trim this and open the channels. Okay, don't worry that the constraints are gone, so that is the reason it is converting to blue. But further we have to give the constraints. I'm just trimming down all the and opening the entries. Okay, and yeah, here. Okay, I'll just trim this instead of trimming the dotted lines, construction lines. And then here also we don't require this, and this. That's it. Yeah, on this end. Okay, and then just press escape and connect these lines. import the lines. Lines. When you just close the, you can create an outlet here. So outlet also you can create of 2 mm in diameter, and one more of 2 mm diameter. Okay. And then we see that it can move now, so there is no constraint. Now what we do is like, so we give a dimension from let's say this end to this end. Yes. Okay, so that is making overridden, so don't select it. Okay, go back, edit to sketch. Now this sketch is free to move. Just give the dimensions to it. Let's see, it is okay, it is moving in the y-axis, right? So just check it and press Ctrl Z. Okay, so now we have seen that this length has to be fixed. No. And so let's try to do some constraints. So first of all, then just draw a center line. And now you can see that it is constrained, and then just draw the length of this so that the complete movement is constrained, and then just trim these entities. Not required. Okay, now nothing to worry. Oh, this one missing here. Yes. Okay, we close everything, and then just create a mirror entity. And entities to mirror is this circle, about take a mirror of the center line. And then trim this entity, and also this one, this one. Do not panic seeing all these dimensions. So it's just only thing is we have given an over dimensions, and delete any one of the dimensions, right dimensions. So yes, now I think we are done with the design. Yeah. Okay. So complete designing is done, and ensuring that there are no open ends. Yes, there are no open ends. And go to features and extrude cut. So in the extrude cut, you can see the complete design is able to cut the lower base that we created, and we create a 1 mm of channel. Yes, it is done. And now after that, as you see, the length of the substrate is 75, but it is more. So what we do is just go back to the sketch, and remember, starting we have given a length of 3 mm just to make it constant. So we can increase this length to 6 mm, so that the complete device design is shifted down, and I think we can further increase it. Okay, so overall it looks like symmetric. And now first part is done. So we have a channel which is engraved into the substrate. Now we have to create the inlets to this, and then go to insert the next part, create a new part, and edit this part. And now we know that we have to create on this, go sketch on this, and then as we see, so we want a similar rectangle, same rectangle first of all, and then we have inlets to this. So let's draw the inlets. One inlet, second inlet. Okay, so reservoir should be inside the channel, so we are not drawing on it. Third inlet. So these are the outlets. So these are the outlets. Now you can try to constrain them. Okay, so since we have given a concentric, and just give the dimension to it. Okay, should be 2 mm. Okay, this is 10 watt. 2 mm. This is also 2 mm. Okay, now so let's try to extrude. So let's try to extrude a 0.5 mm sheet, very thin sheet. Okay, and then you can see the inlets are alone open. Okay, so now on the top of this, we want to create an inlet for our tubings to enter. So what I do, I'll create a center rectangle, and you can use a preferred length. So I prefer 3 x 3. Okay, and you can have the diameter as 1.75 because my tubing diameter is 1.75. Okay, and everything is done. And to do the second thing, just copy this, paste, and then connect this dot. Okay, you can connect this hole to this circle, and we can connect this C. This. And the another one also we can connect to this. Yeah. And now if you want, you can connect to this directly, or the same way you can do the mirror. So I just prefer to connect. Now it is done, so only thing is you can just give the dimensions again to make it fully constrained. Specify the length and this too. Also you can specify the length between this and this edge, so make it constrained. And then you can give the dimension as 1.7. So these steps are not required, but it's always better to be in constraint. Let's give 3 mm. And I'll specify the length on this is 11 mm. and we see that this is okay, this length is missing. What we do is so this is fully defined. Now again you can do the same thing. 3 mm, × 3, and this is 1.75. Now again you can just specify the as 3, and this distance is 7. It's done. So instead of giving the same to this, just delete this. Okay, here few dimensions are deleted. It was a by mistake. Delete. Okay, so the deleted constraint is the this, and in this case the deleted constraint is okay the diameter. Okay, instead of giving dimensions to this, so what we can do is create a center line and mirror the complete entities. Okay, and I can mirror this about this line. So since they are symmetric, you can see this. Go to features and then you can just extrude. Extrude this in 3 mm. So you can see the inlets and come back. So use your complete channel with for 3D printing of developing microfluidic channels, or you can use the same for your PDMS-based photolithography microfluidic channels. So if you want to see the transparent view, you can see the transparent view. So this is how you are completely defined microfluidic channel for 3D printing as well as for lithography. Thank you for your patience.